How do you choose the right op amp for your voltage follower? The main things you need to consider are dynamic range, slew rate and bandwidth, and drive current. So let's talk about dynamic range. Can the op amp take in an input and supply an output in the range of your signal? In your op amp's datasheet, take a look at the supply voltage spec, as well as the high-level output voltage or low-level output voltage, the VOH and VOL, and take a look at the common mode input voltage range to see what the range of your op amp can be. So in this case, for the MCP6496, the supply voltage can be between 1.8 volts and 5.5 volts, so that's VDD minus VSS. The highest the output voltage can be is VDD minus 10 millivolts under these conditions, and the lowest the output can go is VSS plus 10 millivolts given these conditions. The common mode input voltage range is a lot less restrictive, so you can see that the range is VSS minus 0.3 volts and VDD plus 0.3 volts, so that's beyond the rails. You also want to take a look at the plot output voltage headroom versus output current, or another one we might include is output voltage headroom versus ambient temperature. So for the case of the MCP6496, you can see from this plot that as the output current magnitude increases, your output voltage headroom increases as well, meaning that your dynamic range gets smaller. So let's say you're trying to source 4 milliamps, then the highest your output signal will be VDD minus 50 millivolts here. Let's say you're trying to sync 8 milliamps, then the lowest your signal can go will be VSS plus a little under 100 millivolts. All right, let's talk about slew rate and bandwidth. Voltage followers don't have any gain, and so slew rate becomes important when you have high frequency, high amplitude signals and you want to use as much of your op amp's dynamic range as possible. There's actually a pretty simple equation that you can use just to calculate the minimum slew rate that your op amp needs in order to avoid distortion. So the minimum slew rate your op amp needs to have is 2 times pi times the amplitude of your signal times the frequency of your signal. So let's take a look at an example to illustrate why you need to think of slew rate. So the MCP6006 has a slew rate of 1.9 volts per microsecond, and the MCP6496 has a slew rate of 40 volts per microsecond. So we're going to compare the two. So let's say we have a 400 kilohertz pulse signal. So I've already inputted in here 400 kilohertz, offset of 2.5 volts, amplitude of 1 volt. And let's just run a transient analysis. I think I've already got it set up here. So transient, 20 microseconds, and let's push run. So it actually looks like we've got some convergence issues over here. So let's try and fix those. It should be a pretty easy fix. Let's go to convergence options, and let's just do full quad precision and give it one more shot. Okay, so that looks pretty good. But you can see if we zoom in here, you can see how the signal doesn't quite, I mean, it makes it, but it takes a while. I mean, it's more than half of the signal that it's not where it needs to be. So if we compare that to the 6496, let's change it here and try that again. Okay, so you can see that the 6496 is easily keeping up with your signal here. There's almost no distortion whatsoever. All right, last but not least, let's talk about drive current, or how much current does your op amp need to supply at the output. You can take a look at the output short circuit current spec in the data sheet. So for the MCP6496, it can supply 55 milliamps if VDD is 5.5 volts and you're trying to source that current. So if it's 45 milliamps if you're trying to sync it. So if you try to go above that, you'll experience loading effects, and your voltage headroom will decrease, like we talked about when we were discussing the output voltage headroom versus output current. Okay, so how do we choose the right op amp for our voltage follower? A couple of main things we need to consider. Dynamic range, so we had talked about power supply range. We talked about the VOL and VOH, the high level and low level output voltage ranges. We need to think about slew rate and bandwidth of the op amp, mostly slew rate, because if you have high frequency, high amplitude signals. We don't want those distorted because of the slew rate. And we need to think about the drive current of your op amp. You don't want your voltage or your signal to be clipped because you're trying to drive too much current, and the voltage headroom gets shrunk because of that. So if you want to learn more about op amps, check out our other videos in the series. Thanks for watching.